All right, let's get this thing started. Let's get it started. Here we go. All right, so I need to get dy dx initially by itself. So I'm going to go ahead and leave this as y1 plus x squared dy dx. Remove the rest of the garbage to the other side. I get x1 plus y squared. Drop the minus sign because that's, and we're all good to there. Okay, so you need all the y's on one side, the x on one side. So obviously I'm going to move this over to here. I'm going to leave this here, but I'm going to move this back over to there. So with just a little bit of algebra 2, I get y over 1 plus y squared dy dx equals x over 1 plus x squared. Look, those are symmetric, so that's going to be handy. Now I got them separated like I'm supposed to. I get y dy d. I'm going to get rid of the dx on the bottom. 1 plus y squared equals x over 1 plus x squared dx. And I'm ready to do the magic. Integrate both sides. Now, again, they're exactly the same, so I'm doing dy on the left, doing dx on the right, so I'm just going to do it for one side because I'm lazy. U equals 1 plus y squared, so du equals 2y dy. So I know I need a 2y dy, so I'm going to go y. Oh, I already got the y. Hold on, let me eraser going here. Whoop. And I need my brush. Here we go. Okay, so then I've got 2y dy, and I've still got 1 over 1 plus y squared equals, it's still equaling things on the right-hand side that I don't want to think about too hard. And so I get 1/2. The integral of this would be integral of 1 over u du equals, and then I would get 1/2 n of u plus c equals, whatever's the right-hand side, and so I'm going to clean this up as 1/2 ln absolute value of 1 plus y squared plus c equals 1/2 ln 1 plus x squared plus c. Again, the right and the left look the same, right? If they look the same, then the integrals can be the same except for the x's and y's. All right, so now I need to solve for y, right? I'm going to solve for a specific case. Let's isolate for y first, and then we'll solve for a specific case. Okay, so multiply both sides by 2. That cancels out that. Raise both by an e to the, cancels out that, and I end up with, and by the way, absolute value bars don't matter because 1 plus y squared must be positive. So once I get done with, all, I have a problem. I can't do that. Hold on. Here's my problem. All right. So I'm going to first subtract c from both sides, or c from this side. Remember that these c's aren't necessarily the same, so I end up with a weird c. And I end up with 1/2 ln. I'm going to drop the absolute value because they don't matter. There's no way that's going to be negative. Equals 1/2 ln 1 plus x squared plus c. Get rid of multiply both sides by 2, and I get 1 minus 1 plus y squared equals ln 1 plus x squared plus c. I'm going to swing the e across. I get 1 plus y squared equals e to the ln 1 plus x squared. I'm going to use my trick where my e to the c becomes a letter. I'm going to make it k because it's getting really confusing here. I'll move the 1 to the other side. I get y squared equals, sorry, my pen's now deciding if it's going to work or not work. K, what's e to the ln? Well, that's just the original expression, right? So I'm going to end up with 1 plus x squared, because e, to what part is e to make e to the l? It just cancels out, right? Minus 1. And then y equals plus or minus the square root of k plus kx squared minus 1. All right, now I need my specific case. My specific case was when x equals 0, I should get the square root of 3. So I'm going to go ahead and down here, I'm going to write the square root of 3 equals, now plus or minus is not relevant because I need a positive when I get done, so I'm going to drop the negative altogether. I get k plus k times 0 squared minus 1. I get the square root of, I'm going to drop the square roots of 3, so I get 3 equals k plus, that's just 0, so minus 1, so k equals 4. So my specific solution is going to be this, where we replace k with 4, right? So y equals plus or minus, I don't need the plus or minus anymore because I'm talking about the only case that will give me a positive square root of 3 is going to be a positive, so this becomes a square root of, plugging in 4, I get 4 plus 4x squared minus 1, and yes, I would absolutely finish this by making sure that I got rid of the 4x squared plus 3 square root bar, right? Because 4 minus 1 is 3. All right, so that is the specific case. I hope that answers the question. If it does not, give me some more questions. I'll play with them.